And now I have the distinct pleasure to introduce our speaker for tonight. And his, my estimation of him, already quite high, has upped significantly because he took my camera cold and got it to work and took pictures of us. So that's pretty cool because it's kind of a weird camera. This lecture, this plenary lecture has been going on for I'm not sure how long. Somehow Malcolm Bowman and I just don't keep very good count. We can count, but we don't seem to try. But we've had a really amazing array of speakers as plenary lectures, and I think this list is going to scare our speaker this evening because they're very impressive indeed. For example, one of our speakers a few years ago was Andrew Revkin, who pretty much invented climate change journalism and had this very famous writing. He wrote for the New York Times, and then later he was coordinated an organization and a blog and columns called .Earth, which are very, very famous. We also had Wally Broker, who was one of the inventors of marine chemistry in its modern era, and he gave a talk about climate change, and he has had lots of very interesting ideas. We had environmental novelist Ruth Ozeki, who was really one of the finest novelists. She's not that young anymore. I used to say young, but she's really an amazing person, and wrote a book about Fukushima called A Tale for the Time Being, which I highly recommend. It's really a fascinating book. We had Barbara Ettinger, one of the finest directors of environmental films, and she wrote she edited and directed a movie called The Sea Change, which we had here. We've had Carl Safina, who I just noticed is in the audience, one of the world's most distinguished conservation biologists, specializing in pretty much everything. 10 years ago, I used to say he's a great marine conservationist, but there's really no limit anymore to his interests. They're so wide. We've had Bob Sess, who was a professor here on campus, a really, truly great atmospheric scientist, a pioneer in the study of climate change. And we've had really amazing people. Lila June, a very famous Native American poet, which we had last year, and she came with a group called the Road Show of Resistance. And I was kind of amazed that we were able to sneak that in and get support on campus because it was a very political type of performance. And last, I could go on, but we also had Heidi Cullen, and she is the principal scientist of Climate Central, which is one of the most important climate educating organizations in the world. So we really had an amazing array of people, and really lots more, but I'm not going to mention any more. I'm going to get right to our speaker tonight, who is Dr. Paul B. Shepson. He is right now a director of an NSF unit, a very large NSF unit in geosciences and geospace. But he is, in his normal life, at least in the past, recent past, he's a professor, and a professor of atmospheric science. His specialty is atmospheric chemistry. But he's coming to Stony Brook, and he's going to be the dean of the School of Marine and Atmospheric Sciences. So we're really very, very happy and anticipating his arrival, I think sometime this summer. And he will be replacing the great Larry Swanson, who will still be here. And we're delighted that Larry's going to be around. He's going to probably be wondering, oh, there he is. Oh, hi, Larry. I was about to say something very insulting about you, but I'll hold it back. So this is a wonderful thing to have two such stellar people that are going to be together and are going to get along and do a lot of great things together for SOMAS and for the university. So what haven't I said? Well, first of all, Paul comes from Elmira, New York. So he's a son of the Finger Lakes district. I think that's correct. But he's not from the Ithaca's. He's not, at least from the middle finger. But he is a child of New York State, as is his wife. So they're coming home, if you will, from Indiana, and he was a professor at Purdue, and he was a director of an institute whose name is somewhere written down here, but I forget its name. But he has had a long history of doing great science, but also at the same time directing groups of sciences. Just the type of thing that we love to have here at Stony Brook. People who are active scientists, doing stuff that's real and useful for us, but also knowing how to get groups together and do great research. So we're really delighted to have him because of that. And he's very passionate, not only about climate change and understanding it, but communicating it. And if I say any more, I'll be boring you if I'm not already doing that. So let me just say that I am delighted that we have Paul Shepson here as our speaker, and he's going to talk. His title is called Embrace the Change. So Paul, please come up.
Whoops. So, I'm delighted to be here. I see that, and I'm delighted to see that this is a spiritual crowd. I've always felt that applauding before you have heard the talk is a form of prayer. So, good luck with that. We'll see how it goes. So my wife Jody and I are coming home, and we're so excited about coming here. The energy on this campus that we saw today, it's unbelievable. It's different, you know. You should know that there's something special going on here, and we're really excited to be a part of it. And please, I want to encourage you to shed your outermost garment, because it's really warm in here. One of the things, well, let me start also by saying that one of the things I'm really excited about is I've already got a room full of friends. I know a lot of your names. It's happening quickly, and thank you for that. Thank you for the welcome that we're already getting. You're also going to be, some of you getting to know me, or all of you getting to know me better. And the first thing I'll say is I am a professor, Jeff, and that means I like to talk to a fault, and so I will know how you feel when you start throwing things at me, but I am going to move it right along. So speaking of religion, I like to share a little bit about my religion, and for me, that is my creator. I know that I sprung from that planet. As planets go, it's a pretty darn good one, and as we look for life in the universe, I hope that we occasionally take the time to look in the mirror, because it's a special place. So I'm going to be talking a little bit about the planet, but mostly about power. So I'll tell you what I mean by that as I go. It's Earth Day, or Sunday is Earth Day. Today's effectively Earth Day. I would be remiss if I didn't quote Ms. Carson, who showed us a lot about the impact that we have on the earth, but also the impact that individuals and groups of passionate people can have on promoting and developing a sustainable planet. So she should be an inspiration to all of you. Can't really point at this, can you? Inspiration to all of us. Next thing I want to say, in particular to the students, congratulations. You are at a great American university, and that should be exciting to you for a number of reasons. But for me, what it means is to understand that universities are special places. And I have a special orientation about that, because I've spent the last 4 years working in the executive branch, and I just want to say, God, I love universities. But aside from the relative things, universities harbor all of the intellectual resources that we need, complementary resources of all kinds, that we need to bring together to solve grand challenge problems. Universities can and should be an essential national resource. Not just a great place to send your kids to get an education, but an organization in partnership with the rest of the country to affect positive change. We haven't been there, and Stony Brook is the kind of place that is going to help us get there. So again, to the students, congratulations. So the challenges, I'll start out with challenges, and then it'll be a major bummer, and then I'll turn positive. So the challenges that we have are in significant part due to trends in global population. You can sort of see the red light. There we are right there, 7.4 billion. For the students in the room, I'm sure you'll all live to see the 22nd century. So by that time, the population of the planet will have increased by about 50% or so. We'll be up around 11 billion. And it's important to know that all of those people want to have a quality of life, a standard of living like yours, but you are outrageously wealthy. And we are all extraordinarily fortunate. It's important to know that all those people want to have the quality of life that you have, and they're going to try to get there almost entirely by burning fossil fuels. So when you burn fossil fuels, you're trying to take the carbon, and I'm going to get technical like the chemist that I am. The intent is to turn the carbon in the fuel into carbon dioxide, so that's energetically downhill, and all the change in energy is released. And so fossil fuels are a fine source of energy. But the problem is the product is carbon dioxide, and it's not particularly water soluble. It's hard for the atmosphere to get rid of it, and so it builds up in the atmosphere. One of the first things I want to remind us of is the special role that Americans have in climate change in terms of how much of the carbon dioxide that we have emitted. So this is cumulative carbon dioxide emitted into the atmosphere by different countries, and here we are right here, 4.5% of the global population, about a quarter of all the carbon dioxide that has been emitted is emitted by us, followed by China, Russia, Japan, Germany, and India, and that pretty much sums up most of it. But I like to think those of us who are contributing the most to this challenge that's really just about change, and change is annoying to people. It's not necessarily the case that all the change is bad, but it will be annoying to people and it will cost money. And the United States, while not currently releasing CO2 at the greatest rate, China has surpassed us, the integrated total is the greatest for the United States. So, whoops, I just turned it off. There we go. That's really scary. So the carbon dioxide goes into the atmosphere and it pretty much stays there. And so here is a plot of the amount of carbon dioxide in the atmosphere as measured at Mauna Loa, starting in 1958, 2 years after Jody. I'm giving away your age. You can kill me later. After we were born, this fellow, Dave Keeling, thought, well, nobody else thinks this is a good idea, but I just have this sense that we ought to know what happens to this known greenhouse gas and the bottom of the carbon cycle. So people at NOAA, starting with Dave Keeling up to somewhere around there, started measuring it. There's tremendous amounts of information in these wiggles. It's higher in the winter when the biosphere in the northern hemisphere is turned off. And then it goes down in the summertime in the northern hemisphere because it's undergoing uptake into the vegetation. It is partially soluble in water, and so this is a measurement of the concentration of dissolved carbon dioxide in the ocean at Station Aloha. And it turns out that carbon dioxide is an acid. It's a weak acid, but it dissolves in water and makes carbonic acid. And so the pH of the oceans are going down, and there's the data, 0.07 pH units over the last 25 years or so. And there are a variety of marine creatures who can sense that. It affects their productivity, and so on. And so with climate change aside, this is an extraordinarily important development. Now, this is quite possibly the most influential, most important data series in human history because of what it told us about climate change. The measurements were made at the top of the volcano at Mauna Loa. And so 2 weeks ago, in service to you, I went to Hawaii on a pilgrimage. You will find out just the things that I will do for this university. And it starts with I went to Mauna Loa. So I went to the Keeling Building. It's got the Keeling curve on the outside of it. And you know what I want to say to students is, first, go with your instincts. If you think something feels important and not everyone agrees with you, you're smart because you're at Stony Brook. Go with your instincts and be determined, like Dave Keeling was, and maybe a building will be named after you, especially if you donate the cost for that. This is the instrument that's there under glass, really cool, a very difficult measurement that he didn't really understand exactly why he was doing it. Well, now, come on. It's not advancing. Oh, it says no internet. We don't need that. Okay, so the carbon dioxide that we're emitting into the air is causing the Earth's temperature to rise. Humans are causing climate change, and we know that for certain. But we don't know that, I want to be clear about this, because of any stupid poll. We don't know it because 4 out of 5 dentists tell you, or 97% of climate scientists say that climate change is occurring. We know it because we understand the fundamental physics of it, and that fundamental physics leads us to development of climate models that predict what is going on the planet. And they do a pretty good job. All the information that we have says we're causing this temperature increase. So it's 1 degree Celsius or so over the period of since the time of the Industrial Revolution. You know, there are bumps and wiggles, like there's, you know what that is called? That's the hiatus. There's a hiatus in the temperature change. So this is just the change in temperature relative to some average over the last 130 years. There's the hiatus. Well, there's another one. There's one, there's one, there's one. But if you're not trying to obfuscate, then you look at the big picture and you see, of course, the temperature of the planet is increasing. And you know, if I wanted to, I could look at this data like right there and say, oh, the Earth is cooling off. But really, we should have some respect for the experts like Ming-Hua, who spends all his life working hard to understand the planet. And the idea that armchair bloggers will try to convince you that it's something else is a little bit disturbing, but it's a great challenge for students. Your biggest challenge as a scientist will be figuring out what's real and what's not, who's real and who's less real, and we're in exciting times in terms of reality. So one of the realities is we don't experience global average temperature. We experience the local weather. We often remember extremes. So here is the distribution of temperature. Let's say it's the average between 1951 and 1980. Sometimes it's warmer than average. Sometimes we have a day like we had yesterday. It was relatively cool. So this is the world between 51 and 80. Some days are a little warmer, some days are a little cooler, but now we have climate change. And so if I click the button and it works, it will show you that there are wiggles in the data. Some, you know, you have extreme events. You have snowstorms, you have heat waves. Here's 87, here's the 90s, soon we have the Audis. And what you see here is that the distribution has moved warmer. Al Roker the other day said we're having global weirding. We're going to have hotter weather and we're going to have colder weather. You know, I love Al Roker, I really do, but he's wrong. We're not going to have, on average, any colder weather. The planet is warming, and out here we have extremes. So here are extreme warm temperatures that previously we never had. So some of the heat waves, like we have had on the East Coast, they had in Paris, where you can also have poor air quality, they're going to kill people, and they have. And so understanding this and predicting this is really important. And it's really important that we embrace the scientists who are trying to provide a public service of predictability, trying to provide information that everyone can use so that we know how to protect ourselves and how to build resilience in the planet. So as the planet is warming, one of the things that is happening is the Arctic is warming at 2.5 times the rate of the rest of the planet, and that is causing the sea ice to melt. So this is a plot of the volume, the total volume of sea ice on the Arctic Ocean. The blue data is at the end of the winter. It's basically spring total volume. And the red data is the end of summer. It's September. Sea ice. They both have the same slope. 300 cubic kilometers of sea ice are being lost from the Arctic every year. And so that's part of the climate feedback. But it also affects people. So this is a picture of some of our favorite people. They're Inupiat Eskimos in Barrow, Alaska, participating in a celebration of the harvest. It's called Kivik. These people are bowhead whale hunters. Their whole culture is based on things like building umiaks out of seal skin, the way they've done for hundreds of years. There's a harpooner in the front who's using explosive tip harpoons. Not the way they've done it for 100 years, with a line attached to a GPS antenna. And they decided how to go out there by looking at the internet weather forecast and sea ice remote sensing. Very fascinating people. But they have a very unique culture. You know, in the United States, we actually do have some unique cultures. We have great music. We have Inupiat Eskimos. But these people have a culture that's based on the sea ice. The bowhead whales swim from their natural predators, the orca, by going under the sea ice. If the sea ice melts away, they lose this protective shield on top of them, and they will be at risk, as will this culture that is at risk because some of us have to drive an Escalade by themselves to work or to the grocery store to get toilet paper. And we should all think about whether we have the right to change the whole planet. Anyway, climate change is also warming the oceans. About 90% of the incremental heat from the excess greenhouse gases in the atmosphere goes into heating the oceans. About 90%. So climate change is mostly not quite felt by us in terms of atmospheric temperature. The orangish data here is El Nino years. The blue data is La Nina years. The slope here is about the same, but something like 0.6 degrees Celsius warming in the oceans, which has a wide array of effects, including on coral reefs. But also, if you have warmer ocean surface temperatures, the water will evaporate faster. You remember Newton told us that what goes up must come down, so if you evaporate water faster, within 11 days on average, that water has to come back down as rainfall. So we must be on a global average having significantly greater rainfall, and that is not homogeneous spatially, but quite heterogeneous. And we've already observed this in the data. This is just a plot effectively of the frequency of extreme one-day precipitation events in the United States. So we're having more frequent deluges in various parts of the United States, and other parts, often inland or in the west and southwest, more drought because of the faster evaporation. Have I bummed you out yet? As you warm the oceans, the water expands, and so the sea level is rising. I don't need to tell you that because most of you have lived through Sandy and the storm surge and the impacts of that, but over this period, something like 20 years, 8 centimeters of sea level rise, and the rate at which that rise is taking place could increase to the extent that we have increased rates of glacier melting on land. And so this represents a risk to people in coastal environments. An exciting thing to me about Stony Brook, there are so many of them, but it's a marine environment. We've been living in Indiana, nothing but corn and soybeans. But also the challenges in what is happening and how it impacts these 10 million people or so. So this is a plot that results from prediction of how much sea level rise we'll have by 2100. And the areas, some of them having relatively expensive real estate. Jody and I have been spending a lot of time thinking about real estate. You have to be careful what you invest in and what the impacts will be, particularly when we have tropical cyclones impacting on Long Island and New York City. So as I said, the oceans are warming, the pH is dropping, and one of the impacts is on an important part of the way that we feed ourselves. Coral reefs are sensitive to events where they're exposed to relatively warm temperature. This is a plot. These black bars represent bleaching events, severe bleaching events where more than 30% of the corals are bleached. This is from a relatively prominent Australian oceanographer, Terry Hughes. I refer to him a few times, and I think, why am I not citing so much people? Anyway, the point is the frequency of these coral bleaching events is increasing, and in some cases, if the period between bleaching events is relatively small, it's quite difficult for the reef to recover. So these incredibly beautiful coral reefs that sustain biodiversity in the marine environment are at risk, and so Terry Hughes makes the comment that we can have advances through management, but there are changes on the planet that we can't control in the short term, the temperature of the ocean surface and the pH, and so that while it's possible to have healthy coral reefs, healthy ecosystems, those coral reefs are going to be different than the way that they were in the middle of the 20th century. And so we have to embrace the change. Well, that's a good name for a talk there. That there's some change that's in the pipeline that is just going to be very difficult to manage on the short term. So the end of gloom and doom here, it's the case that the world is changing rapidly, but what's exciting, so now we're in part 2 of my talk. First is the world is changing, but the second part is we can fix it, and that is exciting. We can think like Rachel Carson, that we can change the world. And that will be fun for us, fun for our students, but it will also be profitable. If we're going to affect change on the planet, we have to embrace the idea that the things that we do that are big have to be profitable. It's just a fact that we all need to have income that will help us send our kids to Stony Brook and feed ourselves. And so we have to think about that the change that we are voting for, working hard for, has something in it for everybody. So what will we do about these challenges? How will we respond? Well, we are going to stop warming the planet. We have to. And so it's going to happen. That's exciting, but how will we get there? Well, we have to stop burning fossil fuels. It's just a fact. And so, you know, the way that the world was built, it isn't necessarily the smartest way. The way for students, just because the world exists in one configuration, please don't think that my generation knew what we were doing, okay? It's not necessarily the case. But there's exciting technology like solar power that has been around for decades, but as I'm going to show you, it's getting cheaper. It doesn't all have to be centralized. We have centralized wind power, even in Texas. So the largest wind farm in the United States, I think, 22 gigawatts, that's a lot of wind power, is in Texas. There's the Lone Star flag there. If they can lead in renewable energy right in the middle of the center of oil and gas development in the United States, then we can do it right here on Long Island. So this is cool, but it's not as cool and not as important as distributed power production. So what's really exciting is you can change the world right at your home. You can buy an electric car. You can charge it with solar power and wind power that you install on your roof. You can change the world. You can help create the markets that make the costs go down. But it's intermittent, you say. But there's a solution to everything if we just think positively. So I like people who are innovators, who are dreamers, and Elon Musk happens to be one of them. So he's created this battery. It's called the Tesla Powerwall. It can discharge a kilowatt for 24 hours. So if you can recharge on the 24-hour time scale, you can have right now in a semi-affordable way that pays off in just, 5 to 10 years, you can have a completely carbon-free home with secure power. I've heard on Long Island, you better have a generator that's automatic. I'm not sure about that. But anyway, so the automakers know that the world is changing. GM just came out with an announcement in the end of 2017 about their new line of all-electric cars and their vision. So visioning is going to be really important in SOMAS. Their vision is a world with zero crashes, Jody and I like that, zero emissions, and zero congestion. So they are coming out with 2 new all-electric vehicles right now and 20 new models in the next 5 years. That's a big investment. They claim they're going to do away completely with internal combustion vehicles. And at the same time, Ford said the same thing. So the automakers, which are typically slow to change, think this is important. There are other ways that you can make the power to drive your car from centralized power by electrolysis of water and producing hydrogen that will run a fuel cell that will charge the battery in your car. I love it when you hear the bloggers say things like, well, don't you know that hydrogen is explosive? Oh, really? It would be an explosive fuel. That does sound... So again, I love dreamers. Here's an all-electric airplane. I'm a pilot, and so the idea that I could have a jet of this size that's all electric, that I could plug into my house, it cruises at 100 knots. That's fine for 2 hours. So this happens to be a trainer in Europe. Going for 2 hours is about twice the length of an average flying lesson if you're working on your private lesson. So that's just really cool. So back to Elon Musk. Again, I like dreamers. He has a company that stumbles and falls, but it also, I grew up during the Apollo era. And so the idea back then that some private person would launch his car into space and send it towards the sun, and that car would take its own selfies and beam them back to Earth, that's just unbelievable. So we are living in the most exciting time, and climate change is forcing us to change the world. So climate change is exciting as all get out. It's not just big things that we're going to have. It's also big information. So we're in the era of big data. And that big data will help us see and know the truth about the planet. So we'll have satellites. We do have satellites right now looking at the Earth. It will be very hard for people to say, we're not doing it, and the planet is not warming, there's a hiatus. The Earth will speak for itself, and it is doing that. So I want to show you some examples of the big data that tells us what the Earth is doing. NASA launched a few years ago the Orbital Carbon Observatory 2 that circles the Earth, and it looks down and it counts up the number of carbon dioxide molecules in the atmosphere. So here's some data. Across this row is carbon dioxide columns, the warm colors being more, the cool colors being less. So here we are, a lot of sinners here on Long Island, burning a lot of fossil fuels. You see the East Coast. Here's East Asia, South Asia, Germany, and a little bit of France. And this helps the people who are developing emission models that tell us where is carbon dioxide being emitted, so we can think about the most cost-effective ways to reduce it. This is nitrogen dioxide. It's a precursor to ozone, which contributes during heat waves to respiratory stress. So there's an awful lot that we can see about the planet, what the atmosphere is doing, unfortunately what you personally are doing, and we know. So I want to stop this little video if I can. Move it back. Yeah, so geologists have this network called GAGE. It's geodetic stations that the NSF paid for around the United States. And among the pieces of information it gives us is the height of the surface of the crust, where the surface of the Earth is. It turns out that in places like California, we'll focus on California, in the winter and spring, snow builds up in the mountains, and the surface is relatively wet, and it has weight on it. That depresses the surface of the Earth. And so the blue colors here mean depression of the Earth's crust, as measured by this GPS technology. The scale here going down is 10 millimeters. 1 centimeter. We can observe the rise and fall of the surface of the Earth by 1 centimeter with good spatial resolution. So when summer comes and that snow melts and it runs off, the surface of the Earth rises and the data becomes red. So you see the annual cycle, red in the summer and blue in the winter and spring. So let's show you what I can't see without my glasses. Oh, cool. Okay, so here we are. There's a date here, 2006. It's blue, it's red, it's blue, it's red. So you're looking at the seasonal cycle, just the Earth going up and down 1 centimeter. I just can't believe how unbelievably cool that is. Red in the summer, blue in the winter, 2010. This is just fantastic. 2011, 2012. Now it's summer, it's all red in 2012. Southern California never got blue. 2013, it's red everywhere except those 4 blue things. Red everywhere. Why is it red everywhere? Because there was a drought for several years in California. The little blue squares were during the drought, we were drawing water for irrigation and other use out of these deep wells, and that caused subsidence of the Earth where those wells were. So you can see all kinds of things that humans are doing from space. If you have a university like Stony Brook, or you have a country like Sri Lanka, you have a class, you have a student, you can have those people can have their own space program. So there's this new thing funded by my division at NSF called CubeSats. It's just a little satellite like this. We're miniaturizing instrumentation. Here's the scale. The undergraduates who launched this into space, with a little help from NASA, could be SpaceX though, just had an unreal tape measure to give you scale. So they live in space for 2 years. They cost $1 million. That's nothing. NASA originally didn't want to have anything to do with this. We could have a space program right here at Stony Brook. But not just observations from space. We can have handheld observations. So citizen science, we can be measuring air pollutants, carbon dioxide. We can be measuring the temperature of your pocket. I'm not sure how we'll figure this out. Probably glucose in your blood, all sorts of things that will be installed in your cell phone, and Apple will have a separate power cord for every device that you have. But an important question for us is, with all this change and this global market, 10 billion people are going to want to buy renewable energy. To me, the question is, does the United States want to lead? Do we want a piece of this? Or are we going to run headlong towards the 20th century? God, we love coal. In Indiana, when I said, don't we want to make our buildings carbon-free and build, put solar panels on the roof? They told me this is a coal state and we want jobs for our kids. Really? Is that your vision for your grandchildren, that they go down in the coal mine? I think the world can be a whole lot more exciting than that, and the United States should lead. But we should look at the data, look at what's happening. So this is a plot of gross domestic expenditures for R&D, just R&D of all kinds. Here's the United States. These are not inflation adjusted dollars. Here's the European Union. And here's China. So China is taking off in its investment in R&D. We can look a little more closely at specific this happens to be private investment in sustainable energy technology. Here's the United States. Here right now is China is taking off, thinking hard about, well, I don't know what the United States wants, but we want to lead. We want a piece of the market that is every single person who lives on the planet. It's a big market. The other thing that we might want to think about is, where are these people going to be and what are they doing? And so it's important to note that we are urbanites. 55% of the people on the planet live in cities. It's going to be more like 70% or so by 2050. 2/3 of Americans live in cities. In Africa and Asia, it's increasing dramatically. Here's the 50% mark. In places like North America, we've been above 50% for a long time. So we need to think hard about how we're going to manage cities. Well, it turns out that there are lots of people who are interested in this. Bill de Blasio is an example. So we are members of this thing called C40. It's a network of the world's megacities that involves cities getting together, collaborating, and sharing knowledge about how to build a better city, how to do transportation more effectively, how to manage your buildings, how to heat and cool, and so on. Bill de Blasio, according to his Office of Sustainability, has set the ambitious goal to reduce citywide greenhouse gas emissions 80%, does that mean 80% below 2005 levels by 2050. 80% decrease in greenhouse gases. Every single thing we do is made possible by burning fossil fuels. So what this means, if we could actually achieve it, is we're going to fundamentally change everything we do. How we build buildings, how we heat them, cool them, light them, do transportation. How exciting is that? Makes you want to be a mechanical engineer, really. So how will we achieve that? Well, I was urged to say something about my own research. So we'll start maybe by understanding what are the processes, I shouldn't chew on ice while I'm talking. What are the processes that result in emission of greenhouse gases? An important one is methane. So I have this airplane, that's me right there. There's a student next to me with a plastic bag. And we're flying around here down the Hudson River. This is color-coded methane in the atmosphere. Cool colors are less, hot colors are more. The winds on this day were a lovely day. Winds off the ocean, very clean. When you fly on that VFR flyway down the Hudson River, all of a sudden you have hotter colors, more methane flowing out of New York City. So we have figured out quantitatively where that's coming from. It is all coming from the old natural gas infrastructure, from leaky pipelines. And that's important to know. We can just get out some bubble gum and fix them, or some of the pipes can be replaced. New York and Boston both have very old pipes, in many cases cast iron from 100 years ago. So this is a picture of a New York City street canyon. It's already built. Huge amounts of money have been spent, so we're not going to tear these buildings down. They're going to be retrofitted. There's going to be a huge market in changing the way that we heat and cool them, doing things like building green roofs, solar panels on the roofs. There's just tremendous amounts of development that have to take place, and the engineers here at Stony Brook can be a part of that. Solar power is clearly growing like crazy. So here's 1975, the price of a solar panel per watt. You can't do a whole lot with 1 watt. This is when Jody and Rich Winkler and I were sophomores at Cortland. $101 per watt. That was pretty darn expensive. Here's what it is right now, 37 cents, 370 times cheaper for a watt of solar power. And so here in blue is the rate at which people are installing solar power. It's just skyrocketing because it's all of a sudden affordable, and as people do that and the market grows, then it'll get cheaper still. So that's really exciting. You remember I said, well, we've got to have also distributed storage. We have that. This is the trend of cost of the battery systems. And in response to this decrease in the cost of storage, here is the rate of investment, the size of the energy storage market between 2014 and 2020, is a 6-year period. It is projected that the market will increase by a factor of 26. So the world is changing dramatically, and that's very exciting. So we have to rebuild the country. So I'm going to now quote some important Americans. One of them is Teddy Pendergrass. I really like Teddy Pendergrass. And back then, before we knew it, in the time of the growth of the Green Movement, he sang this song, "Wake up all the builders, time to build the new land. I know we can do it if we all lend a hand. The only thing we have to do is put it in our mind. Surely things will work out. They do it every time." Some of you are hearing this. If I sang, you would be even more unhappy than you are. So, but there are other inspirational people, leaders of our country, who spent time thinking about, now they made mistakes. Sure, we all make mistakes, right? It's how we recover from them that matters. But JFK said this at a time when he had a vision that we should put men on the moon. I'm sorry he didn't say we should put people on the moon. What he said was, we choose to go to the moon in this decade and do the other things, not because they are easy, but because they're hard. We were excited by a good challenge. Because that goal will serve to organize and measure the best of our energies and skills, because that challenge is one we are willing to accept, one we're unwilling to postpone, and one in which we intend to win. We really need this kind of inspiration. I often wonder what happened to our can-do attitude in this country, where we decided, let's build a Hoover Dam, and 3 years later, it was done. Of course, we killed some people, so we need to think in the process. We need to think a little more carefully. But we had a can-do attitude, and I sometimes, when I'm having a bad day, wonder what happened to it, but I know where it is. It's right here in this room, in the students in this university. So it's important to understand that you can have dreams and you can make them real, and I'm going to give you an example. So again, the world is changing fast, very fast, and you can be a part of making the good parts of that change happen. Now, so part 3 of we have the technology to fix this is that Stony Brook should lead the way. There is this amazing energy here on this campus. I don't quite know why it's here, but it's really quite palpable, right? So it's expressed already in all the LEED buildings, and there are more being planned by expressing our vision for the way that the planet should be. I'm delighted that's happening here. So there are a variety of expressions of leadership here at Stony Brook that I want to mention, like New York State RISE, the Resiliency Institute for Storms and Emergencies, that was inspired by Sandy. It's all about recovery efforts, but also building resilience, that having the university inform decision makers about how to not let that amount of damage happen again, how to build preparedness. Institutes like CIDER, the Consortium for Interdisciplinary Environmental Research, that has this objective to take advantage of what universities are, a wide array of complementary assets. So to unite them and to partner with government and the private sector, very important. To do that and apply it to complex problems, to engage students who have to build a new land. In teams, you'll never do anything great by yourself, and it's no fun to do things by yourself anyway. And to educate people about the solutions that are exciting, that will build a better country and contribute to the economy at the same time. Did you know that the Clean Air Act that came out at the time of Rachel Carson has a benefit-to-cost ratio of 30-to-1? Regulations do not all cost money. The Clean Air Act and the Clean Water Act have enriched our country financially. And there are people running around saying we can't have regulation. All regulation is evil. Baloney, speak out about that baloney. The Advanced Energy Research and Technology Center that's working on wind, water, geothermal, and ocean energy right here on Long Island and around New York City, and designing more efficient photovoltaic cells. But it's not just Stony Brook, it's Stony Brook being a partner with government and with the private sector. So Andrew Cuomo has produced this master plan that states some of the most ambitious clean energy goals in the nation, including reducing greenhouse gas emissions 40% by 2030, 80% by 2050, so in lockstep with Bill de Blasio. And some of it will involve things like offshore wind. You know, Jody and I hear people say, oh, they're so ugly. Compare these things to a coal-fired power plant. If you don't have one, you have to have the other. There's the Roosevelt Island Tidal Energy Project over closer to New York City that has already done demonstrations about making use of tidal energy. Just very exciting, the array of ways in centralized way and also distributed ways that we can produce renewable energy. Back to the governor, there's Executive Order 88, which says by April 1st of 2020, we will decrease the energy use efficiency of all state buildings, including here at Stony Brook. So we are in partnership with mayors and the governor, and that's exciting. We are integrating the universities into change in the country. So this is part of my message. How am I doing, Tom? no idea. This is a part of my message. Be excited about the power of a university. It's not just about classrooms. It's about translating what we know and what we can think up to make the world better in partnership with the rest of the country. We've got to stop this thinking about universities like they're an ivory tower, and that perception is so wasteful because there is tremendous power here. So, taking Stony Brook as an example, we have all these complementary capabilities. Like, well, we need to partner with Cornell once in a while, right? So we have SOMAS. What a great school that is. It's just a real honor for me to be part of that. The fundamentals in arts and sciences, human health with the medical school, social welfare, the business school, as I said, the solutions have to be profitable. Journalism, I just love Howie. It's going to be a thrill working with him. We need to have students capable of analyzing the difference between truth and fiction. I don't need to say too much about that, right? Engineering, we need to build a new land, better cities. So all of these assets of the university have outputs like centers, the Center for Clean Water, Technology, Engineering is making energy efficient transportation and buildings, renewable energy. SOMAS is working on sustainable fisheries, aquaculture, climate modeling that informs us about the changes and gives us predictability, social welfare that helps us understand the way people think, and that capability helps us develop emergency response planning. We need economic models to understand how the United States can best position itself to lead and to prosper by investing in the future and not running towards the 20th century. So the outcome of all these things are the outcomes that we want: improved human health and welfare, climate change mitigation, cleaner, more livable cities, coastal ecosystem resilience, protected natural ecosystems and thriving biodiversity on the planet, sustainable agriculture and aquaculture, sustainable water use that's so important here on Long Island and near New York City. So we can do all these things, and it'll be exciting. So I'm talking about power. And I hope the students are not all asleep now. This is the most significant, the most awesome, the most important source of power you will ever see. Those of us who lived through the Vietnam War era know that young people can, if they choose, if they're angry enough, change the world. Forget about what this particular one was about, March for Our Lives. But a bunch of high school kids made us talk and think about, oh geez, are us old people really doing the right thing? You know, forget which side of, whether you own guns or not. These people said, enough is enough. Here's what we want. And again, those of us who lived through the 60s and 70s know that students can change the whole world, that they have enormous power. You will never see anything more powerful than this group of people marching on DC. One thing I'll say is that these are not the people who should go out and get arrested, right? They're going to be putting their resumes out there, and if on your resume, well, I spent a month in jail because of, that's not good for them. Some of us who are retirement age or post-retirement age, we can afford to get handcuffed and carried away. And so I want us, that group of gray-haired people that were on the stage, we should be getting arrested and standing up for wanting a better planet. We should lead, and not just leave it to high school kids. But if high school kids are showing some leadership, do not pick on them. Applaud them, please. Okay, so this is my message. You can change the world. Go do it. The world is in many ways stupid. Let's fix it. Really. Just because it exists in this particular configuration doesn't mean that that makes sense. There are consequences of the way that. Have you ever been to a coal-fired power plant and seen this huge pile of coal that gets burned every day? It's just stupid. Let's do this right here at Stony.
Dr. Shepson will recognize you and speak out loud and clear. We don't have a microphone system, so just talk slowly and loudly and we'll be able to hear your question.
I don't recognize you, but...
So I don't know what a LEED building is. I was wondering if you could explain that. I saw the science center out there, so I'm excited.
So there is a process for designating a building as, you know, I can't tell you the acronym, it's something maybe, I'm sure people here, low energy engineering and leadership and energy efficiency and design. So it's a way to encourage and recognize organizations and architects who build energy efficient buildings. And so we have many LEED certified buildings on this campus, and it is something to be proud of. It costs money to build a building, so I know from experience that sometimes administrators, they have a donor and they can build a building with $20 million, but you can build a LEED building for $24 million, and if you're at 18 or so, as the thermometer rises, many universities will say we can't afford to do that. And to me, that's like saying we can't afford to inspire and recruit the best students who care about that kind of leadership. So I applaud Stony Brook. It's doing a great job in this.
So, are you up for convincing the governor that he should support public education? Higher public education, which he doesn't.
You betcha. You know, I would love to speak with the governor about my thoughts about partnership, and that investing in these technologies are good for the economy. New York State can lead, but universities should be a key partner. This is the crucible for innovation. So if you're not investing in the source of some of your innovation, then you'll lag behind, and you'll lag behind economically. And so I would love to work with people who are smarter than me, people from the business school and political science and so on. But you have that all in one university. I would love to try, and please help me. There was somebody else back here. It is Friday night. I thank you for giving us some of your Friday night. I'll get to you here.
I just wanted to thank you for presenting tonight. I'm a county legislator, and I'm very happy to mention that, you know, working with Stony Brook and Kate, some of the professors, I'm looking to partner. I'm looking for government to partner with our educational institutions to not only bring the kids, bring the graduates into life, because we have to change the process. If we don't change the process, that global warming will take over, and it doesn't look good for us. But you know, we're going to hopefully be working on a presentation to bring out to the communities, to the other legislators, to the civics, to the schools, and you know, it's important that we have the latest scientific information and research, and I'm really looking forward to working with you.
Well, thank you. Likewise. I might have mentioned I like to talk, but I also will have the privilege of leading a school full of people who are a lot smarter than I am, a lot more capable than I am, Kate is among those. There are lots of people that we can engage in that kind of partnership. So I can't speak for the university or SOMAS yet, but on July 2nd, I'm ready to go. So please, let's talk. Back here, yeah.
Hello, thank you for coming both now and to the school institutionally as well. I'm an older returning student who left a financial career for a career in business to retrain for here for STEM while I work as a manager at a pharmacy, and I've had the opportunity to come here, but I've also had the necessity to retool my life because of, in the last recession, a lot of people were let go, whether they or their field did anything wrong or not. And I hope I'm not over-personalizing it, but I think that many of the people, not just powerful people that like business as usual or have a traditional point of view, but a lot of ordinary people. You have taught at Purdue University. I'm originally from Indiana. There's a professor that I liked and respected here that I met at the beginning of a course in the life sciences. He's like, you know, I've been around this country. I lived here, I lived in Massachusetts, I lived in Maryland, I grew up in California most of my life, and I see all these quote, and I see all these people, you know, behind that guy and this other guys, and I just don't know who the hell they are. It's because he's a college professor who's been on the coast all of his life. I guess I'm just wondering, like, it's not, they're the people from Indiana that want coal work or factory work or traditional retail or whatever. They want that for their kids and grandkids because it's how they and their parents and their grandparents were successful. How could someone, I guess I'm disaffected as well. I guess I'm just not of that point of view. And I talked to them about some of the things you've talked to, like my cousins, and they're in their 40s too. And my one cousin, he actually said, well, that's your education talking. How do you get past that as someone from, frankly, what I assume is a liberal intellectual at a public state university? How would you bridge that over instead of talking about LEED buildings and we have to, this presumption that we have to decarbonize the planet when
many
frankly
of us
the country
have made their fortune by carbonizing the planet. Let me just say that one of the things I've learned is that, you know, everybody's human. And people are often afraid of real, you know, tangible loss. Like, I worked hard in utilities that burn fossil fuels, and it paid for me to send my kids to the state schools, and you're scaring me. And, you know, the first thing to do is not argue, not blog in an angry way, but listen and show some respect for people who've done the best that they can, and they understand the current world, and the idea of changing it is scary. And so, you know, I think sometimes just listening and having a conversation about what your vision is and how the jobs of the past can transition into the jobs of the future. But there are realities out there that we have to be really sensitive to. That why are we change averse? Because sometimes there are winners and losers. And hopefully if we have thoughtful change, the net will be in favor of the winners. But we have to be very thoughtful and compassionate about people, you know, the disaffected, that obviously we've learned when the disaffected can really matter, right? People really matter. And instead of arguing with people about things like climate change, we should listen and you know, talk about the things we have in common, which we love. We love our kids and our grandkids, and we all want the same thing. And we're not enemies. we're on the same side. You know, one of our great challenges is this really damaging political divide. We should not have two sides within our country. You can see it's doing damage. So I think a lot of it is seeing the commonalities that we have.
That might be the best note we can use to end. So let's thank Dr. Shepson.
Thank you for the opportunity.